9.5 Polar coordinates. The polar coordinate system is a two-dimensional coordinate system in which each point on the plane is determined by a distance from a reference point and an angle from a reference direction. The radius is really the distance measured from the pole. Our pole is going to be our origin. The angular coordinate is really the angle that's measured from the polar axis counterclockwise, which looks a lot like the angles we've been dealing with from our unit circle. And in fact, our unit circle is actually graphed on a polar coordinate system, and you'll kind of see in a minute what I'm talking about. So our pole is the reference point of the polar graph, that's our origin, and the polar axis is a ray from the pole in the reference direction. Our polar coordinates are labeled r, theta, which should look somewhat familiar from needing that trig form of our functions, that we were just dealing with in 6.5, trig form of our numbers. And these are plotted on our polar grid. So we have our positive x-axis is now going to be called the polar axis. Okay. Our origin is the pole. The first coordinate r is the radius or length, or think magnitude, of that directed line segment, which is essentially a vector. The angle theta is measured in radians, the same way that we've been measuring angles this entire time, from that positive x-axis up until the angle. And then we also want to note that even though we are measuring theta first when we are finding, like when we go to plot, it's always the number and then the angle. So radius, angle. Okay. So what we want to do is plot this. Oh no, they moved on to the next page. That's okay. We want to plot the coordinates 2, pi over 4, and the other one we want to do is 2 pi over 3. Okay. So what we want to do is make sure that we are plotting in the angle pi over 4. So pi over 4 would be the angle that is from the x-axis to, well, halfway, right? So this would be about pi over 4. And if you notice, our axis, our whole grid looks different. Pi over 4 would be here, right? So what we want to do is plot a radius of 2 out, okay? So I'm going to erase that. We know that pi over 4 is that spot right there. So pi over 4 is this angle over here. And we want a radius of 2. So when we're counting our radius, each of these circles counts as a number. So 1, 2, 3, 4, 5, 6, and so on. Each circle is one measure out, one radius unit out. So we want to go in the direction of pi over 4, and we want to go out 2 for our radius. So from the origin, we're going 1, 2. That's on that pi over 4 marking, and it's 2 circles out. All right, the next one we're going to do is pi over 3. So pi over 3 would be this angle right here, right? This would be our pi over 3 angle. And we want to go 2 circles out again. So from the origin, we're going to go 1, 2 circles out. Remember, every circle is 1. All right, for the next one, we want to go to negative pi over 6. Remember, back to the unit circle, negative pi over 6 is actually going down this way. So 11 pi over 6 is the same thing as negative pi over 6. 3 is going to be 3 circles out. Remember, 1, 2, 3. So in that direction, 3 circles out, that point that we are plotting is right there. And then 11 pi over 6 looks exactly the same, as we know. 1, 2, 3, 11 pi over 6 and pi over 6 are equal to each other. So it should be that same point on the 11 pi over 6 line, 3 circles out. All right, and lastly, we want -1, -3 pi over 4. So first we're going to find that angle, -3 pi over 4. Remember, negative means we're going down instead. So 1 pi over 4 would be over here, 2 pi over 4, 3 pi over 4. So -3 pi over 4 is over here. Now, 1 would be going in the direction of that angle. -1 means to go the opposite direction. Think vectors, right? think about your vectors here. You would be going in the opposite direction. If you had v or negative v, you'd turn around and go the other way. So this is that kind of angle we would be going on. The other direction would be going this way. So 1 in that direction is going to give me the point over here. 1 circle, we just want to go the other direction. Okay. So in rectangular coordinates, the ones we are used to from Algebra 1, x comma y, is, you just have your regular plain old x and y graph, nothing super special here. That Cartesian, it's called your Cartesian plane, your rectangular coordinates. They each have a unique representation. So there's only one way to write this point. That's it. Only one way. That is not true for polar coordinates. As we just saw, you can have the same point plotted twice if we use coterminal angles. Or we could really change it up and also use the negative on that r coordinate, making you go in the opposite direction. So in reality, there's about 4 different ways to write each of our points. So, for instance, here, this is that coterminal, right, when we're adding 2 pi. So, I hope it's what I can spell. My goodness, coterminal. R theta and r comma theta plus 2, getting a coterminal angle, is just one of the ways we can represent the same point. But another way would be to use negative and then to change what your angle is. So what we can do is really kind of change this up in general. We can do r plus, or r comma theta plus however many circles we want, so 2 pi times n. Or we can do negative r, go the opposite direction, and then make sure we head to the opposite quadrant. So that would be pi plus or minus, really we could subtract circles too. There'd be nothing wrong with that. Really half a circle. So we would say, let's see, we would do 2n plus 1 pi. Okay. All right, and n could be really any integer here. But we can very easily look at the graph and come up with these answers as well. Our pole is being represented by 0 comma theta. Literally any angle is good. 0 comma anything is going to be the origin here, because that would mean we're not moving at all. So it doesn't matter which angle we head, we're not moving. So 0 comma anything is going to be our origin. So what we want to do is plot, oh, I'm so sorry, I don't know why this did this to me. We're going to plot the point 3 comma negative 3 pi over 4, and then we want to write it 3 more ways in addition to this. So let's plot that point. Negative 3 pi over 4 is over here. 3 circles out, so 1, 2, 3. There's my point. I want to write this 3 different ways. So the same point, I'm not plotting any more points on this, but I want to write it 3 different ways. So we could get a coterminal angle, right? We could find what this angle actually is. This angle is also 5 pi over 4. So we could write this as 3 comma 5 pi over 4. We could also write this using 3 being negative. So if 3 is negative, I want to be looking at the angle that is in this direction. This is the angle I want to be talking about so that I head in the opposite direction. So that angle could be pi over 4. Or that angle could be, let's see, if it was going to be negative, it could be negative 7 pi over 4. Okay, so now I have 3 different ways of writing that same angle, or that same point. All right, so we're going to do the same thing. Running out of space here, we'll do B up top. Why not? All right, so over here we'll do B. I'm sorry, this got all messed up when I switched it to a PDF. All right, so we're going to plot 2 comma 3 pi over 4. 2 comma 3 pi over 4. 3 pi over 4 is right here. And 2 circles out would be this point right here. All right, so I want a few more ways of representing that same point. One thing that we could do is just get a coterminal angle. So the coterminal angle there, if we take away 2 pi, is going to be negative 5 pi over 4 if we went from the other direction. Okay, so we have 2 comma negative 5 pi over 4. The other thing I can do is think about it as being negative 2, which means I need the angle in the opposite quadrant, which would be this angle right here. So that could be 5 pi over 4, or sorry, not 5 pi over 4. That could be, let's see, that would be 7 pi over 4, sorry. All right. Or if I wrote this as a negative, that'd be negative pi over 4. So we could use negative 2 comma negative pi over 4. But these 4 points are the exact same point. We're just writing it different ways. All right, last one. When I have 0, negative pi over 4, that is on the origin. I can write this any way that I want. Anything will represent that point. So we could use 0 and then literally any angle that we want to use here, and it would represent the exact same point. It doesn't matter the angle really because we're not moving. So we cannot move in any direction and we would still be not moving at all.